you have 3 tests, 3 times 18, so giving you 54 mark. Then you have another 6 mark with me on assignment. Okay, I am thinking now how to give you assignment which less stressful for you. Okay, I may give you full mark free for you. Okay, don't tell anybody. Okay. Halo.
Okey,
Dengar tak?
doktor, dengar.
Diam-diam Mervin, diam-diam This is pandemic, because I know you are very enthusiastic to be in the class with me. But my boss is coming. Okay. So what to do now? I present now your entire screen. We go to that. We go to that. And then we go to this is fun. Okay. Subject. Can you see my screen here?
Yes, doctor.
If you can see my screen, should be good. Okay. We do friction today. Okay. So we have two kind of friction: dry friction and fluid friction. So that one you will do in fluid mechanics too. Fluid friction. Okay. Fluid friction we will do in a fluid mechanic too. So subjected if you pass a fluid mechanic one. So today we will do on dry friction only. Okay. So it's so simple. If you have a object, something like this, object, okay, in object, say a box, okay, if you push that box onto your rack, which a force of P, you will have a friction force occurs in between the surface and your object. So this is the things we call it as a friction force. So it should change color into green better. So okay, so you have it as we call it as a friction force. Okay, so it is a tangential to the motion. The thing is not moved yet. Okay, the thing is not moved yet, but you have a force, we call it a friction force, that acting opposite of your movement, opposite of your movement, opposite of your movement. So if you plot, okay, say if you have object like that, okay, so if you put force P is equal to 0, it means no force apply on it. Friction force also 0. Okay, friction force also 0. When you increase the force P, and then the when you increase the force P, also friction force also will increase. Okay, so this is the diagram looks like. Okay, when you increase the friction force, okay, you will see the friction force also will increase from 0 to a certain level. Okay. At one stage, the object will move, and then the friction force will reduce a little bit. This is from the testing. Okay, and when the object move, so the friction force is constant. Is constant. So we have two friction force. Okay. So one is when the object is still in equilibrium, it doesn't move, and another situation when the object is moved. Okay, we have two force there. The first one is force M. Force M, okay, is a maximum static friction force, where the static friction is become maximum. Okay, and the second situation where the kinetic friction force, okay, where the object is in the motion, when the object is moved. It look like, imagine here, it look like you. Okay, you're learning very hard now to learn the statics. Okay, at one stage, you will see your knowledge in statics is maximum. If your knowledge in statics maximum, you can see the rest of the subject is going to be very simple soon. Okay, that's how we learn the statics. Or for those who are Muslim, okay, you can imagine this, which during the equilibrium, you are learning the muqaddam. Okay, you know muqaddam? Ya Hassan, you know what is muqaddam? You're learning
Actually, I don't know, sir. But
there is a Arabic words. We written it alif, ba, ta, and so on how they practice this reading before they read the Quran. Okay, so if your muqaddam is good, and then you can easily read the Quran. So it's so simple. If the object is still not in the motion, you use mu s. Mu s is coefficient of static friction, and if the object is in motion, you use a kinetic friction, mu k and also mu s. Okay, it's all given for you. So from the experimental and this and that, okay, so we can get the mu s and mu k is always given. So this is from the experimental. Metal on wood, okay, metal on wood, okay, metal on rock. We have a standard of mu s. Okay, we'll give you an examination, don't worry. So if you have the object is still in equilibrium, you keep you putting force P there. Okay. So the first thing to do is to draw the free body diagram. Okay, to draw the free body diagram. So this is force P. You apply force P there. You have the mg going down. You have the friction force. You have the normal. Okay, and then you have the resultant of the resultant between the normal force and the friction force. And then you have the theta. Theta is measured from the normal force. Okay, theta is measured from where? From the normal force. So it's so easy. Tangent theta is equal to mu s n over n. So tangent theta is equal to mu. Okay, tangent theta is equal to friction of the force. Okay, or mu s is equal to tangent theta. So I think you know how to do this, right? Tangent theta is equal to that and that. Okay, that's it. Statics. So that is friction. So simple. Okay. Okay. General procedure for you to answer the friction. You have to draw the free body diagram first. Draw the free body diagram first. Okay. So there are 4 categories of friction. Normally, category 1, all external forces are known. Determine either the object is in equilibrium or in motion. Category 1. Okay. That is category 1. And then we have category 2. Category 2 is a famous one. The block is on verge of motion. Where, what does it mean by verge? It almost to move, but it's still in the equilibrium. It is about to move. So it not involve mu s. Okay, it not me. It doesn't involve mu k. Because the object is still in equilibrium. And then this, and we will do this. Category 3 is involved with the motion. Most likely, we will skip this. We will skip this. You will do this in dynamics soon, next semester. You will learn more in dynamics next semester. Okay, subjected to if you pass this subject again and again. Okay, that is category 3. Okay, then that is category 3. And category 4, friction involved with the rigid bodies. Okay, the friction that involves with rigid bodies. So this is the part that we are interested for a test and so on. Okay, right. Okay, so now we move on to this first category. We move on to the first category. We move on to first category. Okay, category 1, it says that determine either block is in equilibrium, okay, or in motion. Then find the magnitude and direction of the friction force. For this case, you are given a block there. You are given a block. Okay, that block. 500 Newton going down, and 100 Newton onto your right of the block. Okay, 500 Newton is a mass of that one. The question asks you to do analysis, to evaluate either the friction, either this block is move down or it move up. Okay, or either it move up or it move down. Okay, so the first thing is you don't have to worry at all if this analysis. You draw the free body diagram correctly, sayang saya. So kamu tak draw free body diagram. Kamu tak draw free body diagram. Itu yang kami nak marah ni. Tapi tak marahlah sayang. Kamu tak draw, you don't draw the free body diagram. That's how we reduce 1 or 0 half mark from exam 1 and so on. Statistics engineers, you have to present it. The analysis of mathematics applying to the structures. Okay? You have to draw. So this is the structure of the problem. So this is my analysis. So mathematics, we know that you are the best analysis in the world because from your matriculation results or from your A level, from where and this and that. You have to draw the free body diagram. Okay. So everybody still got chance to get A, don't worry. So okay, draw the free body diagram correctly. Okay, as an engineers, okay, you should, what to do now is you should well predict this force either going up or going down. Okay, so this is the free body diagram. Okay, 500 Newton going down. Okay, 500 Newton going down that way. Okay, you have a N going up and friction force F. Is the friction force. Okay, friction force. Okay, it's a friction force going up. Okay, friction force going up. Okay, this friction force going up. This is you assume the object is almost falling down. London Bridge is falling down. So when I was in the United Kingdom for my study, also my children at your same age, they always menyanyi. When the London Bridge is falling down, London is falling down. So satu lagi lagu yang dia suka menyanyi adalah Eat an Apple a Day, Keep the Doctor Away. You menyanyi juga kan? Siapa pun tak jawab saya punya lawak. Okay. Okay. So look at me. You have to do also the best practice. You do the axis in the same plane with the inclined angle. So easy for you. It is easy for you. Okay. So it is easy for you. So if you want, I can draw, edit, take a snapshot of it, because some having problem to resolve this correctly in the examination. So which one cos, which one sine, and so on. So we go to this, we go to here. Where's my, look, oh, okay. Please, enlarge it. Okay. So what to do now? You resolve the force into x and y, where one of the axis, either x or y, is inclined with the surface, with the surface. All right. So then you resolve all those forces into I and j. So I shouldn't do this because this is your mathematics. So what to do now is you resolve that. Okay, component into x and y. 90 degrees is 90 degrees to the axis here. Okay. You are now where? From Kuala Lumpur to Zanzibar. So you don't have direct flight. So you have a taking flight from Kuala Lumpur to Dubai. And then from Dubai to Zanzibar. Okay. So what should be angle here? What should be angle here? What should be angle here? Hello. 30 degree, yeah. So we learn a lot of physics and mathematics during this school time. 30 degrees here. Okay. And then you also resolve that force. Okay. And into X and into Y. Okay. The direction must be that direction plus that direction is equal to that so that one is this component is okay, go to there. That one is a component of what? So this is 100 sine 30 degrees, and this is 100 sine 30 degrees. So here also 30 degrees here. Okay, so that component is 100 sine, no, 500. That one is 500 sine 30 degrees. Okay, that component is 500 cos 30 degrees. And then you resolve it into X and Y and so on. So that what they did, the component of in X, okay, in X is 100 cos 30 degrees, okay, 100 in X you have, in X you have to the 100, this is cos. Saya pun dah lah orang 100 cos, okay, in X, so saya padam takut confuse you, so saya padam, you guess, saya pun jam. Tak ada student sini. I really hoping that 100 cos 30 degrees. That one. So in X, you have 100 cos in X. Summation of force in X is equal to 0. Nothing else. You have force F plus 100 cos 30 degrees and minus 500 sine degrees at equal to 0. Then you can get F is equal to 164 Newton. I shouldn't have a problem with that. Okay. So you have a force F is now, your force F now is going to be 164 Newton. Now you're going to analyze it. Either the object is falling down or object is still in the statics. Okay, so this and this, and then possibility, answer F is correct. So positive answer. Negative answer is that is incorrect. So it is in opposite way, so means that the block is in a motion. So either it is in statics or it is in motion already. So you can get N, get the N first. N is summation of force in Y is equal to 0. You have N, okay, minus 100 sine 30 degrees in X. Summation of force in Y is equal to 0. You have N minus 100 sine 30 degrees.
Doctor.
minus 500 cos 30 degrees that equal to 0. Yeah.
Would you mind to explain it again?
Yeah,
I
sayang.
missed some part.
Which part,
I
sayang?
actually didn't understand why we are like doing this 100 cos 30 degree plus f. What's the function of f here?
What is the function of f?
Yeah, like why we are
You
adding
mean?
the f.
F is a friction. It's a friction that occurs in between the surface. It's the friction force. Because when the object move, okay, or it tend to move, okay, when it increase the force, you have the force that acts in opposite direction of the motion. Okay, this is a frictional force, right?
Okay.
This is a frictional force. The F is a friction. Now you're going to analyze the friction force. Okay, then you get the N is that. N is 483. So there are two possibility. Okay. There are two possibility. Compare which force F with the magnitude of maximum static force. So in order for you to check, okay, either, object is in the motion or not, is at this point, at where the static force is going to be a maximum, is here. This is your checking point. Is that point. Okay, checking that point. So the two possibility there may happen. Okay, the first one, F that you get greater than force maximum. F you get is greater than force maximum. Of course, the block is on with the moving. Okay. So the object is using mu kn. The object is motion. Either the block is tend to move, but it is still in equilibrium. Fm is greater than F. To check. Okay, Fm is greater than F. So the first thing is you get the Fm first. Fm is equal to mu s multiplied by n. Okay, mu s 0.3 is given, n is 483, and you get force m is 144. So you got your first m here is 144.9 Newton maximum force. So, but you get force F that you get is 164. So force that you get is 164. So the object is in motion already. Okay, the object is in motion already. So the true value of F is mu k. Okay, mu k multiplied by n. Okay, mu k is 0.2 and is this. So in actual fact, your force is only 96.6 Newton. Okay. All right. I give you 3 minutes to understand it. First thing is you evaluate the force that you get. Okay, the force that you get at the beginning either is greater or less than force maximum. If it is greater, the object is motion. If it is less, the object is still in motion. Okay, we move on the most famous one for test, category 2. Okay, category 2. Okay, category 2. So I give you 5 minutes, okay, to look to understand what does mean in category 1. I'm going to toilet. Orang tua punya, orang tua. Siapa yang mak atau ayah dia about 46 years old or less?
I'm more.
You are more, huh? How old is your dad, if you don't mind?
60.
Huh?
10.
60. Oh, still young. Huh? Still young, huh? Okay. You are the youngest, ada yang?
Second youngest.
Second youngest. Oh, you're not the second child anyway.
No.
No. Siapa yang, who is a second child here? Second child syndrome, we call it. Second child syndrome. Who is the second in the family? We call it second child syndrome. I am the second in the family, you know.
I'm second, doctor.
You are like, sometimes you are like macam tu lah, Aiman, betul tak? Is that true?
Lain macam mana tu, doktor?
So you learn, you study, you surf internet. What is second child syndrome? Okay, no, it's not going to appear in the exam. Don't worry, Okay, I give you some time to understand the concept in category 1. Okay, concept in the category 1. Okay, I will move to category 2. I move to the category 2 in 3 minutes. Give me 1 or 2 minutes for me to go to the toilet. Okay. Where's my pen just now? My pen. Haha, I left this pen in the toilet. Funny. Hello, everybody with me?
Yes, Doctor.
Okay, we move on to the second category. Second category is the famous one. So the block is on verge of moving, but it's still in equilibrium. Okay, the coefficient of static is known. So it's so simple. Okay, it's not moving yet. Okay, it is not moving yet. So determine the range of force P so that system in equilibrium. Why it say that force P in the range? Because the object may falling down or it may moving up. Okay, it may falling down or may falling up. So you do two analysis. The first one is assuming the object may falling down. Okay. And the second category is you do the object may falling up. Okay. So you want me to guide you on this to do this analysis?
Yes, Doctor.
Yes, okay, I will do that for you. Okay, okay, we do. So we do file, take edit, take snapshot. I'll do the question for you. This is the question. Okay, edit. Oh, edit. Copy. This is the question. Okay, category 2 is the simplest part. It's the famous for us to test you in the examination. Insert Home, new slide. New slide. Okay. That is the question there. Okay. That is the question. That is the question there. So that is 25 degrees. So that one is 25 degree. Okay, I enlarge it for you, the question there. Okay. So the situation now, it may falling up or it may falling down, this situation. So you do the analysis for it may fall up or may falling down. Okay. So it may, so edit, take a snapshot of it. That is the things that you have to draw first. This is the things that you have to draw in your examination. Okay, home, new slide, this. These are the things that you have to draw in the examination. Okay, we give you mark, the free body diagram. So if the object is falling down, if the object falling down. Okay, this is in engineering. Okay. Another situation is where copy, insert, boom, slide. Another situation, it may falling up. Okay, edit, take a snapshot of it, copy. Then you do the analysis of it only. Okay, so draw this. Mention to draw this. The second situation, if the object if the object move up, okay, like that. So you know this is from your mathematics. This is 45, this is 25, and the angle there is 20. Okay, get the angle that line with these forces, with the x and y axis. So I don't think you have problem with that. Nothing to worry about this. Just resolve all the component of forces into x and y again. That's it. Very simple. Very straightforward. So draw that. Resolve that forces, all forces into x and y. So that is 1p cos 20. That is p sin 20. And then also this is if this is 25, so you have a component there plus that. Okay, so that there is 25. So you have, this is component what? This is component of p cos 20 degrees. That is a p sin 20 degrees. Okay, p sin 20 degrees. That one here is 25. That means here is here. So that's perpendicular to here. So there is a component of p. Here is p. Let me check. Okay, just okay, P in 400 here, X 400 here, X is, this is 25. Okay, this is that. Okay, if you enlarge it, okay. Okay, so in here in X is sine. Okay, X sine 35. Okay, so sine 35. So this is P 400 cos 25 degrees, and that is degree. That's it. Okay, summation of force in X is equal to 0. What do you have in X? Okay, in X you have 0.2 n, normal force, 0.2 n plus P cos 20, whatever you have in X, minus 400 sine 25, that equal to 0. Is that true? Okay, and then summation of force in Y is equal to 0. You have N, okay, N, okay, plus P sine 20 minus 400 cos 25 degrees, that equal to 0. N minus 400 sine plus pieces. So you do the simultaneous equation, you get P is equal to 111 Newton. So, so you shouldn't have a problem with that. You have P is equal to, so you have only unknown P and N. So you do whatever that you like. You can get N is what? P is equal to 110.6 Newton. So N is it's not stated here, but most important things is 110.7 Newton. 110.7 Newton. You get first P. So P that you get if the object may be falling down. The London Bridge is falling down and so on. Okay. Second situation, if the object is falling up, so the difference is only the what? The only difference is just what? Is the direction of the friction only going down this time. Okay, because we assume the object moving up and then friction will goes down. That's it. Okay, that's it. Nothing changed in the principle and so on. Okay, so you resolve it, the force again. That is resolve that force into X and Y. Okay, so that is unchanged. There to there. That one is okay, 400 cos 25 degrees. That one is 400 sine 25 degrees. Now you have here Okay, that one is component of P cos 20 degrees, and that one is P sine 20 degrees. So summation of force in X is equal to 0. What do you have in X? Negative 0.2 N this time, okay, plus P cos 20 degrees, okay, minus 400 sine 25, everything goes to 0. Summation of force in Y is equal to 0. What do you have in Y? Is N, okay, force N plus P sine 20 degrees, okay, minus 400 cos 25 degree, that equal to 0 everything. So then you do a simultaneous equation and so on. Tell me so you do two unknown, two equation P and N. So we get here P is equal to from your calculation given in the book, P is 239.6. P is a 239.6 Newton. So the range of P is in between, okay, 110.7 to 239.6 Newton. That is your final answer. So there is a two possibility there. Two possibility, okay. Possibility it may falling down or it may going up. Okay, if it is going up, force P may 239.6, and if the object is falling down, the force P is 100 and about 111 Newton force in that directions. There is a force in the category 1. Or category 2. Okay, this is in category 2. Okay, in category 2. So we're not going to touch category 3 because that involves dynamic, because it involves the motion soon. That you will do this in dynamic next semester. Okay, we do the last category that we do is we have a fourth category, okay, fifth category also, okay, involve with more bodies, okay, more bodies, okay. Actually, I'm also interested. I should tell you that we have a category 5. Category 5 is the simplest one, okay. So we move on to category 4 first, okay. Category 4, look at that. Okay, this is the category 4. Determine the smallest force P to start moving. To start moving. To what? To start moving. The first situation, the cable AB is intact. The second situation is when cable AB is removed. Okay, look at that. So, don't worry, don't panic. Ready? Okay. If you're ready, I can draw from here. The second situation is the cable AB is still intact. Cable AB is still intact. Okay. You're taking force. You apply force in that direction. Okay. So most probably the object of 20 kilogram will move into the right. And then you draw a free body diagram of a 20 kilogram mass only first. So simple. Okay, 20 kilogram mass. What do you have? You have mg. You have n1, and you have mu s1 and tab. Tension in AB. Okay. So in X you have N minus that in Y. Straight away can get N. Straight away can get the table tension in AB. Straight away. Look at that. Okay, look at that. So easy. It's not possible for N for the force friction to go to the right. It must go to the left because the object is tend to the right. You have to do a correct prediction on this. Correct prediction on that. Okay. You have to do what? You have to do a correct prediction on that. That's it. Okay. And then what to do? You do a analysis at point 40 kilogram. Do the 40 kilogram. Ya,
Nak tanya,
Tanya.
sebab dia cakapkan yang ni kan dia dah start to move. Jadi friction force tu itu ada sama arah dengan force kan ke kanan. Ke kiri dia.
Yes. Dia ke kiri sebab determine the smallest feet to start moving. It's not moving yet. But it start moving in because force P is moving to the left, and no, the mass 40 kilogram is moving to the left, and then of course mass 20 kilogram will move to the right a little bit. It almost to move, but it doesn't move yet. But the friction must be on to the left. Okay. And then you get the TAB. And then you do the analysis for the 40 kilogram mass. Okay. For category mass, how to do that? Just do the free body diagram of this one only. What do you have here? First one is force P. Okay, force P. You have TAB there. Always out of the point. You have a normal now. And then you have a friction force. It must go to the right. Because in opposite of direction, force P, we are pulling this structure to the left. The friction force must go to the right. Must go to the right. Okay, and then you have, of course, you have a mass of 40 Newton multiplied by 9.81, and you also have normal one again to the body. Normal one again, but you have a frictional force there, mu s n 1. But this time n1, you know n1 already, but this time the frictional force in between is 0.4. 0.4, because that friction force also acts in this surface also. It's act on that surface also. Okay. So you do the analysis and get that. and force P is 392 Newton. And you can do a checking of it. This is checking. Okay. Do that at home. Be careful there. You have a frictional force also at there. Be careful. Okay, because you have a first object is subjected to only one force friction, okay, on the lower surface, but force 2 is subjected to a 2 force. Is subjected to a 2 frictional force. Okay, that's it. Then get the force P. So if the second situation, if the cable is removed, no tension, you don't have to tension. Okay, it's so simple. No frictional here. Okay, no friction here. You have a 60 kilogram down force, force P going on the left. Okay, force P on the left and normal and mu s there. So you have force P is equal to 235.6 Newton. That's it. Okay, I give you a few minutes to look into third category here. No, fourth category. We don't do third category. I just want you to remind it back. Okay. Do revision at home on friction. You don't have to memorize. Try to understand every single step here. Okay. In particularly why you should have that. Many students miss this. Don't miss this. Many students miss this force friction between force 20 kilogram and force 100 kilogram. The first force 20 and 40 kilogram. Why it not appears in the second situation? Because it's no motion. It's no motion. It means that no frictional at all between 20 kilogram and 40 kilogram force. Okay, I give you a few minutes to relax to look into a third category.
Doctor.
Yeah.
So which means start moving means the object still haven't moved yet, still not in motion, still in static.
Are you asking this one or the?
Yeah, this one, because the question asks that this question shows is start moving. So start moving means it's not in motion yet.
Not. Yes, sayang.
Still
No.
consider static.
Yeah. When he says start moving, it's not motion yet. That is to kill you. They give you mu k to kill you. Okay, mu k is not used at all. Good question. Siapa tanya tadi? Who is asking me?
Me, doctor.
Who?
Yong.
Yong, good. Saya tak nampak you, Yong. So, aduh, yang mana satu Yong? Dah ada boyfriend Yong?
Tak ada.
Good question, Yong. When it's not moving, it's not moved yet. Mu k is not used. Good. Good. Why? When you move cable A and B, no force there, no friction there, no friction in between 20 and 40 kilogram here. Because force, the frictional force in between there is zero. That's why you don't have a friction there. Understand this very clearly. Okay, I will finish. Don't worry. I will finish. Okay, we do the last one. The last one is the famous one. The frame that involves with the machine problem. or 2D problem that involve which 2D rigid bodies. That involve 2D rigid bodies. Okay, but don't worry. Okay, please have a read. Please have read example this. I will come to you. That one is involved with 2D rigid bodies. Friction that involved with rigid bodies at point A, that point here and that point there. You have a friction. Okay, the dotted point, you have a friction there. Okay, it says, okay, position of 8 kilogram, 8 kilogram at A is what is maintained by structure BCD. So look at that structure. You are pinned at here. You attach to the spring to the wall, and then you hold the structure block A by this friction attachment. Okay. So if the friction between A and B is 0.25, so here is you have friction 0.25, and between block A and wall is 0.25. Okay. So and the block A is on verge of falling down. It's not moving yet. It's almost. So mu S is used. Okay, so determine the force on the spring and direction at B and D. The first thing to do is to draw a free body diagram of A. So free body diagram of A, so simple. So since you have two different mu s and on the both surface, so n is not different. N is not the same. So this is the first one. The since it tend to merge to verge down, so friction must going up. Mu s multiplied by n, 0.25 normal one, and on this side is a 0.5 multiplied by n, normal force. Okay, that's it. So easy. So then you have anyway, if you do the equation, okay, you can get this n is equal to n1 is equal to 1, n is equal to n1, 169.2. Try to do this. So this is simple. Fx and y is equal to 0 there. Okay, then you have n1, particularly n1 equal to n. So draw a free body diagram at point D of structure B, C, D. So where is the boundary of it? We did many times. So we did this many times. So this is the boundary of it. So you have force T unknown. So you have N1, but it must go to opposite of the first one. N1 is on this to the right, and N1 going down. The friction force going down. Okay, this is normal force. Okay, this is normal force. Then this is the frictional force, and you have dx and dy. So it's so simple. Taking a moment at point D is equal to 0. You have n1 multiplied by 0.8 t multiplied by 0.8 that equal to 0, and you can get d. Then summation of force into nx is equal to 0. You can get dx. Summation force in y is equal to 0. You get dy. Okay, do that. Please do practice it. Please to practice that. Okay. So we have 5 category of friction. Make sure you well understand all these 4 only. So we're not going to do in the category 2. So we file, we save it. Then we try to do example. Okay, one example if possible. We still have time. Go to here. We go to desktop. We go to statics. We go to friction. We go to friction example. So you have many example there. Many example there. Okay, this is so easy. Okay, determine the magnitude in friction. We did this. Okay, we did that. Okay. We did also this. To start, okay, all the same concept there, same thing. Okay, question 8 is not there. Oh, I like this question. Okay, determine the, I like this. 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 So don't know why I say that many times. I like this. 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 Okay, we try to do all together with you. So what to do now? Edit. Take a snapshot of it. Okay, I will finish in 20 minutes. Don't worry. Select a copy. Move there. Boom. New slide. That slide. Oh no, this is not there. Control Z. It should be here. New slide. New slide there. Okay, move here. Okay, can we do this all together? If the coefficient of static blah 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 is 0.3, determine MB, menteri besar. Okay, MB, determine MB when the block A is on merge of going up. Okay. On merge of going up. Okay. So what to do now? Okay. Are you with me? Hello? Last one. Okay, this is the last. Okay, and then you are free to go lunch and then pergi makan. Okay, look at me on how I solve it. So easy. So draw the free body diagram of the first structure. I try to do first part, you do the second part. Draw that object there. Was too thick here. It's too thick. You have an object there. How can nak tak cantik langsung? Erase. There is 30 degrees. Okay, what are the forces acting on that particular structure here? So you have then they have unknown T. You need to connect this tension that because that tension, that cable is attached mesh M and mesh B all together. And then you have here normal. Okay. And since it moved to incline, moving up, okay, it's moving up there. So you have a friction going down. Okay, is equal to 0.3 N. Okay, it's 0.3 N. Okay, so resolve all the forces that not inclined to X and Y into that. So that is 30 degrees. So that is component of, so here is 30 degrees. Okay. Here is time 9.81. Here is, yes. So that is component of 10 by 9.81 multiplied by sine 30 degrees. Okay. That component there is 10 times 9.81 multiplied by cos 30 degrees. Okay, that's it. Summation of forces in x that equal to 0. What do you have in x? In x is negative 0.3, and in x, okay, in x plus t, that direction should be there, that should be going down. Okay, so minus 10 times 9.81 multiplied by sine 30 degrees equal to 0. Okay, summation of force in y equal to 0. What do you have? N. Okay, it's so simple. N minus 10 by 9.81 cos 30 degrees, everything goes to 0. Then you can get N is what? And T is what? Tell me, what is N and T? Tell me what is N and T, sayang. Huh? Tell me, N and T. So the N is straightforward. So just plug in into that, you can get T. Hello, N is what? T is what, sayang? I'm finishing. Penat lah. Tell me what is N, what is T. Tulis, buat calculation. Hello, sayang, berapa N, berapa T, sayang? Oh, dah cerita dah, N 85. Saya tak nampak, orang tua, N 85 Newton. Okey, N 85 Newton, pandai lah, you ni best lah kelas saya online ni, kelas saya face to face, oh wonderful lah. N is 85 Newton, and tension is equal to, tension equal apa sayang? Tension is equal to 74.54. 74.54. 74.54 74.54 Newton. Okay, get that? Why do you need that? The most important thing is you need this. Okay, you need that. So in the second situation where you have the plane is 45 degree there, 45 degree. Marah saya kalau saya tulis dalam pen draw erase, medium erase. If I draw using a red color, so you have that. Okay, you have here 45 degrees there. You have a block there. So you have T. T must be always out of the point. You know T this time. You know T. T. That's why we need T just now. T is look. T is 74.54. 74.54. T is 74.54, and you have mg going down. Okay, mg going down there. Mg going down. Okay, let me tell you, someone switch on the phone please. Tell me if block A is verge to moving up, what happened to the block B? What happened to block B?
Verge of moving down.
Block B will go down.
Going down.
Okay, block B will going down. Which direction should go for the friction?
Going up.
Up.
Going up.
Pandai. Pandai. So mu S n. So it's given by this one is given by 0.3 also. So 0.3, erase it. Okay, no, this is not cantik. This is 0.3 by, this is (0.3) by n1 this time, different n. So you have here n1 different than the previous n. Okay, different the previous n. Okay, you can do then you resolve that force and y first. That is the component of what is mg. Okay, so you don't know, the question asks you what is the mb. mb multiplied by g, mb. Okay, so that is component mb multiplied by g cos 45. That is mb multiplied by g sine 45. Sine 45 degrees. Okay, you may do x positive that way and y positive that way. This is x, this is y. So summation of force in x equal to 0. What do you have in x? In x is negative 0.3 and 1 in x. Okay, what have you have in x? In x, that should be in that direction, and that one also should be in that direction. In x is negative mg that plus mb multiplied by g multiplied by cos 45, that equal to 0. Okay, That's the only that you have in X. No. You have another force.
T.
Force T. So I write. Yes, force T sayang. Saya pun 8 nasi kot Okay, saya do it again. Erase. Medium error. I put it there. In X. Terus sini Okay. Summation of force in X equal to 0. You have negative 0.3 and 1. Okay. Plus MBG is 9.81 multiplied by cos 45 degrees. Okay, plus MB. Okay. Minus T is equal to 0. What else you have in this? These are the only that you have, right? Summation of force in Y that equal to 0. What do you have? N1 minus MBG sine 45. Everything goes to 0. So you use G is 9.81. Okay. So you have two unknown there. So tell me in 5 minutes. Okay, tell me in 5 minutes what is MB. Okay, this is the calculation. Okay, this is the calculation. So this is the calculation. Okay, tell me what is your MB. Oh, someone MB. Okay, MB is 15.34 kilogram. Thank you to Yong. Sudah makan Yong? 15.34. 15.34 kilogram, and we don't ask you about N1, Yong, N1, Yong. Hello, Yong. Yong. Hello. N1, 106.1, 106.41, 106 N1. 106 point something, 106.41 41 Newton. Okay, MB. Okay, MB. Okay. Okay, different. Okay, this one, this N. Okay, we have many cases in the examination. They assume N here. Okay, look at me. I'm finishing. N in that plane is not similar to N in that plane. Different. Okay, different. Okay. Okay, that is we answer for question A. Question B says that block A is in the moving down. So you just change that N to going up here, and that one to this one going down. Okay, try to do this at home. Try to do second part at home. Okay, insert home slide page. Okay, try section B at home. Okay, tell me this afternoon. Tell me this afternoon what is MB. Okay, what is MB? Tell B, section B, when the thing is moving, the structure is moving down. So it means that mu 0.3n is going up for the first object. T doesn't change in the direction. Okay. For that one, T also doesn't change in the direction. Okay. But just the only which change is 0.3 and 1. So tell me what is the MB. Okay, I'll save it here. Save. Save. In the desktop. Where is my desktop here? Here is desktop. Week 10, lecture 2. Week 10, lecture 2. Save. File, save. Okay, try to get MB if the object is in the opposite direction. With that's the end of our meeting today. Bye-bye. Bye-bye. Bye. Assalamualaikum. Bye-bye.
Thank you,
Thank you, doctor. Thank you, doctor.
See you next week. Okay, bye-bye. Bye-bye. See you next week. Bye-bye.